So in this video, we will discuss the IC 60870-5 protocols. So let's try to understand the IC 60870-5 protocol. It is based on the reduced communication reference model, which is called enhanced performance architecture. In short, we call it as EPA. Why EPA is important? Because it includes only three layers of OSI model for the data communication. Mainly the physical layer, data link layer, and the application layers are utilized for the data communication. So the companion standards in the IC 60870-5 protocols are IC 60870-5-101, which is serial communication protocol, and IC 60870-5-104, which is network protocol. Both are derived from the IC 60870-5 protocol standard definition. So if you see IC 60870-5-101, in short we call it as 101 protocol. So the physical layer of 101 is based on ITU-T, that is International Telecommunication Union Telecommunication Standardization. So the interface specification has been taken from ITU-T, and the frame formats required for data communication are defined in IC 60870-5-1, which is defining the link layer level data formats. Now, the transmission procedures at the link layer level are defined in IC 60870-5-2. At application level, the ASDUs, that is application service data units, are defined in IC 60870-5-3. Then application information elements are defined in IC 60870-5-4. Now various application functions which are required for various user processes are defined in IC 60870-5-5. So these are the documents which you can refer for 101 protocol. Now in case of 104 protocol, the physical link, network and transport layers are standard TCP/IP layers. So they follow the standard TCP/IP transport and network protocol suite. In case of the application layer of 104, it will follow the same standard as we have in case of 101. So the ASDUs, that is application service data unit, and application information elements are derived from 101. The user process, that is various application functions required for the data communication, are also derived from 101. Now let's see the protocol structure. So we'll compare OSI 7-layer architecture with EPA 3-layer architecture. So in this case you will see that we will have physical layer, data link layer, and then we will have only the application layer. So all the intermediate layers, that is network, transport, session and presentation layer, are not available in EPA. Why it is structured like this? Because we want the short reaction time. More the number of layers, the headers and footers will increase the size of the data frame, and the making the data frame and removing the headers and footers will take some time. To make the reaction time short, we utilize enhanced performance architecture. This will also help in reduce transmission bandwidth. So it will help in both ways, like reducing the time as well as the bandwidth of data transmission. Now let's talk about 60870-5-101. So 101 supports unbalanced, that is master initiated message, and balanced, that is master or the slave initiated message data transmission. 101 supports point-to-point and multi-drop communications links carrying serial bit low bandwidth data communication. The link address and the application service data units, that is ASDU addresses, are provided in 101 for classifying the end station and sectors which are there under the same network, so that the application knows that the data has to be sent to which process or which device using these addresses. The data is classified into different information objects, and each information object is provided with the specific address. In 101, we have a facility to classify the data into high priority, that is class 1 data, and low priority, that is class 2 data. And the 101 protocol will tell you how to transfer the low priority as well as high priority data using separate mechanisms. In 101, there is a possibility of classifying the data into different data groups. So typically 1 to 16 data groups you can create. So this will create different data groups to get the data according to the group by issuing specific group interrogation commands from the master side. Now in 101, we also have the cyclic and spontaneous data updation scheme. 101 also has facility for time synchronization for the transfer of files. Now let's see the various layers in 101 protocol. So in 101 we have physical layer, data link layer, and the application layer. So the physical layer contains the information bit which is of 8 bit in length. Then we have a start bit and stop bit and the parity bit. In case of data link layer, the standard frame format utilized for the data communication is FT 1.2. So this is the frame format which the IEC 101 is utilizing for asynchronous data communication. Now at the data link layer level, the station address field length is of around 1 to 2 bytes. For unbalanced mode of data communication, it will transmit message which are categorized into two priority classes, which we have seen in the previous slide, that is class 1 and class 2 priority data. In case of balanced mode of data transmission, the messages are not categorized into class 1 and class 2, hence all messages are sent with equal priority. The network layer is not available in 101 protocol. At the application layer, the length of header fields for data structures are as follows. We have station address of around 1 to 2 bytes, which is user defined. ASDU address is of 1 to 2 bytes. Information object address is 2 bytes, and cause of transmission is also contains 1 byte. There are various ASDUs which are utilized for the data communication. Say ASDU 1 is for single point information, ASDU 2 is for single point information with time tag, and so on. Now let's see the data frame and the structure of ASDU in case of 101. So in ASDU, for the first block required is the data unit identifier, which will contain type ID, variable structure qualifier, cause of transmission, and the common address of ASDU. Then we have the various objects, and the respective object information will contain the address of the object and the information element and the time tag. So it depends how many objects you are sending in one ASDU, and accordingly you can have multiple objects to be embedded in one ASDU. So now this ASDU will be part of the data payload in the link layer frame. So here the ASDU will reside and the header of link layer will contain the frame length, then the start bits, and then control field and the address of the link layer frame, and then checksum error verification bits. Now, as the balanced data communications are point to point, the link address will be redundant in that case, but it is included for the security purpose. The ASDU contains the address of the controlling station in the control direction, and the address of controlled station will be provided in the ASDU when the ASDU is in the monitoring direction. So basically you will have the control or monitoring action from the controlling station. So when you have control direction, that is you are sending command, then ASDU will contain the address of controlling station, and when you are acquiring the data, then the address will be the control station address. Important thing in the ASDU frame is that the unique address is provided for each data element. So you might have seen each object will have corresponding information object address. Now in IC 60870-5-101, how the data exchange happens. So if you are having the balanced data transmission, the master station will send the request message for either data or request for any confirmation, and then the slave, that is the RTU or maybe the end device, will send the acknowledgement. So after sending the acknowledgement, since it is a balanced transmission, the slave can also initiate the data transmission. So after the acknowledgement, it will start sending the response message, which can be the form of the user data or any confirmation which was expected from the slave device. And when the master receives the information, it will send the acknowledgement frame back to the slave. Now in case of unbalanced transmission, since slave cannot initiate any data processing, the master will send first the user data or confirmation expect request to slave, and slave will acknowledge. So this will basically initiate the data communication, and then when it gets the acknowledgement, it will send again the request for user data, and then it in the return it will get the response, or it will get NSEK. So NSEK is nothing but the requested data not available. Now in case of balanced transmission, at link layer all devices are equal, and it is restricted to point to point and to multiple point to point configurations. In case of balanced data transmission, the collision is avoided by using full duplex point-to-point connections. Generally, we utilize RS-232 or RS-485 for such kind of arrangements. And the other option to avoid the collision is the designator master posts the slaves on the network to get the data. Now, in case of unbalanced data transmission, only master device can transmit the primary frames. Collision avoidance is not required because only the master can initiate the process and slave cannot initiate any data exchange. If the device responds NSEK, that is requested data is not available, then master will try once again to send the request, that is in the form of primary frame, until it gets the response or the request has got timeout error. Now let's talk about the 104 protocol. So 104 is based on data transmission via Ethernet. So standard TCP/IP Ethernet protocol is utilized for the data transmission. You can see that 104 is an extension of 101 protocol with the change in transport network link and physical layer services to suit the complete network access. Here the application layer of 104 is same as that of 101 with some of the data types and facilities which are not utilized in case of 104. So 104 offers considerable benefits compared with the serial data communication in terms of higher level of safety because it utilizes the standard TCP/IP level security for the data communication. It has a flexible network layout because it utilizes a standard TCP/IP framework. It has numerous network utilities because it utilizes the TCP/IP layers. It is simplified management of connected device. It utilizes the TCP/IP functions to manage the various connected device. Reduced time and cost of maintenance and servicing because the TCP/IP is well-known network architecture and the skilled manpower is available. So the maintenance and servicing will not be a challenge. So when we compare 101 and 104 protocol architectures, we will see that the 101 will contain only physical data link and the application layer, and on top of that we will have the various user processes running. In case of 104, we will have physical data link, network and transport layer, and then we have the application layer, and on top of that we have the user processes running. So the application layer and the user processes are same in both of the protocols, while in case of 101 the data link and physical layers are different from the 104. Physical and data link layer is different in the sense that it follows the standard IC 60870-5 guidelines for the physical and data link layer functions. While in case of 104, the physical data link, network and transport layers are part of standard TCP/IP architecture. So because of that, the data link as well as physical layer in 101 and 104 are different. So the operation of the lower layers of 60870-5-104 is completely different from what we see in case of 101. Here these layers correspond to all the layers below the application layer. That means the layers below application layer are different in both of the cases. The architecture of these layers are more concerned about how the message transport happens. So here mostly the concern is how point to point or multiple point to point data communication happens, while in case of 104 the main concern is how the data is transported over the network.